Hello students, welcome to my YouTube channel Data Guru Akash. And in previous videos of this Python visualization with Matplotlib and Seaborn series, I have talked about how to customize your plot, how to create scatter and line plots. Now in this video, we are going to look into how to create subplots, create multiple small plots in one single Matplotlib plot. And as well as we are going to see how can you create bar graph, pie charts, histograms, boxplot for data analysis, and all other types of graphs for data analysis. So let's see how do we create subplot. So for creating a subplot, you can first we have to create a figure object, right? We can have, let's say, figure object. So let's say fig equals to this, figure is equals to figure object. And then I can use this figure to plot the subplot. So dot add underscore subplot, and here you can pass the how many different plots you want, right? So here you have to pass the grid, how you want to divide this whole area into different subplots. So let's say if you want to divide them into 4 subplot, that 2 by 2, so it will be like this, right? So one plot will be like this. Let me just show you. Okay, so one plot will be like this, and one subpart will be like this, and you will have 4 subplots. So this one subplot, this one subplot, this subplot, and this subplot, right? This is how you divide into 2 by 2, right? You see, now 2 by 2 means 2 column here, 1 column, 2 column, and 2 rows means this 1 row and 2 row, right? But similarly, you can divide into more complex cells. For example, you don't want to divide into 2 by 2. So let's say you want to only divide with 2 columns with no row, right? 2 columns with no row means only this. Let's say only this. So you see, this plot has been divided into, this is 1 column, this is second column, and means this is one subplot. This whole thing will be one subplot. This whole thing will be another subplot. So there are 2 subplots. So you have to divide into in your mind how you want to make it. So now this is a 1 row 2 column. So 1 comma 2 thing. Okay. And if I want to make it like this, so it will be 2 by 2. If you want to make it like, say, something like this, so it will be 3 column, right? And 2 rows. So it will be 2 comma 3. Now it is 2 comma 4. And similarly, you can divide whatever you want. Okay. So let's see by doing the coding itself. How can we do this? So add subplot. Here you need to pass. Let's say you only want to create 2 plots, right? So, and that to 2 column, 1 row. So 1 row, 2 column, 1 comma 2 comma 1. So 1 comma 2 is 1 row, 2 column, and 1 means this is the first one of that. So AX1 you can pass is equals to like this. Okay, so this is the first one. Similarly, out of this first one, you can have the other one as well. Let's say AX2, you can pass 2. And now you can see here there are 2 plots. Okay, there are 2 plots, and so basically this is the first one. You understand this 1 comma 2 thing. Okay, I'll give you one more example. So let's say I want to be 2 by 2, right? 2 by 2. So there will be 4 graphs, right? There will be 4 subgraphs if the figure is 2 by 2. So let's say this is third one, this is fourth one, and here this is third one, this is fourth one. So now you see this graph is 2 by 2. Okay. Now whenever if you want to plot something in this one, you can use AX1. If you want to plot something in this one, AX2, this one AX3, this one AX4. Okay. Similarly, this one AX1, this one AX2, and so on. Right? If you don't want, let's say if you want to make it 2 by 3, means 2 row 3 column, and you don't want to plot, let's say, the middle one. Let's say this is 5th one, this is 6th one, and this is similarly. You can make it. It's just a name. Okay. So you see, 1, 2, 3, 4 is not there, and 5th, 4th, 5th are there. So that's why, these plots are. If you want to add them as well, you can add them as well. And you can plot them. Let's say, how do you plot the figure into this? If you want to plot something into this, you can simply have, the same code. Let's say this, you want to plot in that. So all you have to do, instead of plt.plot, you can do, let's say, ax1.plot. So the same thing has been plotted into ax1. Let's say if you want to make this plot in ax2, you can make that plot in ax2. ax2.plot. Okay. Now you see this plot is in ax2. So similarly, you can do this, right? You can do something like this, and do not forget at the end plt.show. Right? If you do not do this plt.show, you'll be getting this particular thing as an output. It is the returning image of the cell, not showing the cell. If you remember the print and return difference between print and return, so it's the same thing. Right, so that's how you divide into plots and plot them. Let's say you want to give them the title, x-axis, y-axis. So there is one change in that that you can do. I'll show you. Let's say you want to do it in ax1. So instead of plt, once again you can do ax1 dot ax1 ax2 ax1 sorry ax1. Right. So what have we done? So instead of x label, you can do set underscore x label. X label is not the method. Set underscore y label, set underscore title. So now you see here you have set the x label, you have set the y label, you have set the title. Similarly, you can do for the this particular subgraph as. I hope I'm making sense and you are able to understand it. Similarly, you can also do in this case as well. Let's say you want to plot something in this one. Let's say ax1 or ax2, whatever. You can simply just say copy the code here. In any graph, if you want to plot, right? So you see in the first one, it has plotted. Let's say instead of first one, if I've been selecting the third one. So since third one is not there, right? So either you can give it, it's just a name only, right? You can give it the third one only. But here you know that this is the fifth graph. Okay, so that's why if you are the correct name, so that is fine. But yeah, let's say you want to make it in the fifth one, fifth one. So you see it is plotted in the fifth one, and the same thing has been added. So this is how you divide the data into different plots and then plot them in as a subplot. So these are the subplots. So that's pretty much a fit with the subplots. Now we are going to look into different types of graphs that you can plot and understand your data. So for example, let's say what kind of a data can be represented with the bar graph. So basically there should be one categorical and one value. The value will be the height of the bar and category will be the each and every graph. Okay. So now let's say I have the students and their corresponding marks, let's say in one subject, not only in all subjects. So let's say these are the marks and these are the name of the students. And if you simply want to create a bar graph, so for Atul, it will be 90, for Bhavesh, it will be 34 and so on and so forth. So what we can do is we can simply do plt.bar. plt.bar. And you can give the, the names and the marks. So you can give the names, comma, marks. And you see here we have got the graph. If you want, once again, let's say if you simply wants to create the larger graph, so you can give the, figure size as well. So yeah, so it's a very large graph, large figure. Let's say I want to make it 10, comma, right. 10, comma, let's make it 6. So this is the bar graph. Okay. Once again, do not forget to use plt.show. Right. And that will remove that variable name. Let's say if you simply want to control the width or control the color, all those things you can simply pass in here. Let's say once again, color is equals to, let's mark it the color as green. So the color will be green, I think. color we need to pass. No, it's sorry. I'm passing the figure object. Here I need to pass it. So now every color is in green color. If you want, you can also control the width as well. Width is equals to, let's say, so width is nothing but the value that you'll pass, that will be the ratio of the empty area and the occupied area. If you pass 1, so that means there is no empty area. If you pass 0.5, that means the half empty area and half the occupied area. See, the width of this bar is exactly the same width that is left in between. That means 0.5, right? If you want to make it thicker, you can make it 0.8. So you see, so whatever area is left is nothing but 4 times larger is the area of the width of this bar. So that's it. You can make it 0.6 or whatever you want, you prefer. Let's say you want to make each of them color different, so we can simply, let's say, bar list is equals to this. So this will be a bar list, and if I check the bar list, so let's say bar list of -1. So the last one I want to see, Animesh has got very less marks, 30 marks, and I want him to fail. So bar list of last one, right? 5th one. And if I do dot set color, I can set a different color to that color, and I can pass, let's say, red. Now you see, this one has been marked as red, means this Atul has not passed it. Sorry, Animesh has not passed. Right. If you want, you can also do the same thing, the whole thing as, the instead of bar, if you bar H, so basically in bar H, it does not take width. So it will be, whole thing will be, horizontal bar graph. So this is how you create a bar graph. Okay. Now coming to the next thing. So for this, all the bar graphs or any kind of graph, you need to understand a little bit of, statistics. I mean, I say a little bit of, but in order to understand it properly, you need to have a statistical knowledge at some extent. You must have a statistical knowledge. If you do not, then you will not be able to understand it. So for example, this histogram is nothing but the bins of the data and how many, the frequency of the data is shown on the y-axis, how many times the data is appearing. The bar will show, the height of the bar will show that. Okay. So now, for example, there is something called normal or Gaussian distribution. So let's see what exactly normal or Gaussian distribution is. Okay. So let's say here we have np dot normal. So this is the normal distribution. So here I'm passing the, mean, the variance, and then how many data points I want. Let's say I want 10 data points. So the mean will be around 0. Variance will be around 4, right? You can check the mean and the variance. Let's say I'm storing into X. And if I check X dot mean, you see it's very close to 0. And X dot var, if I do, sorry, this is standard deviation, not variance. So it's around 4. So since this is a normally distributed data, right? I mean, since this is a random data, it will not have exactly whatever you have passed off. Okay. It will be around that, but it will not be exactly, because it is a random data point. So let's say you want to have, let's say, 100 data points in this data. And then what you want is, you simply want to plot a histogram. So all you have to do plt.hist, and you can pass the data. And you see here it is basically there are fixed number of bins. If you see here, by default, it will have, see how many bins. By default, it has 10 bins. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So it has 10 bins, and it's nothing but a kind of a bar graph only, where the width is 1 actually. Okay, in the previous one, if you have said width 1, so there will not be any difference in this data bars. So that's the same thing. And once again, do not forget to do plt.show, otherwise you'll be seeing all these cluttered material over here. If you used it, so it's clean. Okay. Now See, plt.hist, and I can also define my own number of bins as well. Let's say instead of 10, I want it to be, let's say, 15. So now there are 15 bins. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these are total 15 bins in this case. See, this is basically following the normal distribution. So by looking into the graph, you can understand what is the distribution of the data, how the data is distributed. Let's say instead of 100, if I pass 1000 data points and then plot the same, you can see this is how a bell curve or a normal distribution look like. Most of the frequency will lie around the mean, and then based on the frequency of the data, it will be lying around this. Let's say instead of 1000, let's say if I have 10,000 data points, right? And even I declare the number of bins more. Let's say the number of bins is 50, right? Now you see, now you can start seeing more smooth graph. Let's increase it even further and increase it to 100. And now you can see here. See, it's perfect looking bell curve, right? So it's normal distribution. Since this data is normally distributed, so see the random dot normal will automatically generate normally data points, and this is how you can plot the histogram. Histograms always shows you the distribution of the data, how data set is spread, how data set is distributed across its whole range, and that is one example that has been shown you with the help of this normally distributed data. So if you want to see your nature of your data, whether that is following the Gaussian or the normal distribution or not, so you can simply go and check. The next type of curve is basically plot that we are going to look into is the pie chart. The use case of pie chart, where can we draw the pie chart? So unless you want to see the percentage ratio, there is no need of pie chart in here. So let's say there are total, in some college, there are total 100 students, like in some college or sports academy, right? There are total 100 students. And out of those 100 students, how many are playing football? How many are playing cricket? How many are playing tennis? If you want to see their percentage or their, ratio, then you can use this pie chart. Or else, let's say you have some product, like you have some shop and you have some product and you want to see what revenue comes, how much revenue comes from which product, then you can do that. So if you want to see the ratio overall, right, so you can do that, like population ratio. Somebody says like how many percentage male, how many percentage female, and how many percentage some others are other genders are there. Or you can simply verify in the age group, like 0 to 10, 10 to 20, 20 to 30, how many percentage people are there in this different age groups, right? I have some different data points. So let's say there are total 100 ice creams, and out of this, 30 are from mango, 23 are from chocobar, 12 from pineapple, 21 from butterscotch, orange, butterscotch, and rabdi kulfi. So let's say this is the data of the ice creams, and I simply want them to be, the in the pie chart. So what you can do, all you have to do pie, and you can give the ice cream data into this ice creams, and you see you have got this pie chart. See, once again you are getting all these things. So what you can do, plt.show, divide this, and you can also give the names as well. Names, labels is equals to names this time, right? So until you pass the name, you will not be able to see which color belongs to what. So this is chocobar, this is mango, this is rabdi kulfi, this is butterscotch, this is orange, this is pineapple. So based on all this, it has simply plotted them. So there are some other customization in this, like you want to make it bigger, you want to make it larger, right? You can also go and create the figure object. And once again, if you want to do any modification, let's say want to make lines in here, right? Or highlight anything, right? So you can simply go to the plt.py chart, the official documentation, and you can go and check there how can you do whatever you want to do. So that is pretty much of it. One other thing that is left with, consider it as an assignment. So I try to figure out how you can see the percentage. There is one parameter might be there. All you have to do is just find out the parameter and pass, and you'll be able to see the percentage here. As of now, you are only looking into this particular just the comparative analysis. That's it. You're not looking into the numbers. You just see how can you print the percentage as well. If not the parameter, then maybe you'll have to do a little bit of maths in this. That's it. Once again, let's say there is something called box plot. So let's understand the box plot as well. For example, let's say this data we have the tabular data. Mainly we'll be dealing with the tabular data in our day-to-day tasks. So here we have a data 2D data where we have 100 rows and 3 columns. 100 rows and 3 columns. Okay, so I'm randomly once again normally distributing the data. 100 rows and 3 columns, and then let's see if I want to create box plot. So we have to simply plt dot box plot, and I pass the data. You see, for each plot, it has for each column, it has created each box plot, and then plt show, plt dot show. So this box plot is showing nothing but the distribution of the data. So you see here, this is the 0 percentile minimum value. This is the maximum value. This is the median value. This is 25 percentile. This is the 75 percentile. Like if you know what exactly a median value are, or what exactly the, so this once again tells you about the data distribution, where the most of the data is distributed. Is there any outlier or not? So these points, out of points, can be thought of as an outlier, right? Outlier is basically detected based on the IQR, interquartile range. So based on this, I think it has one interquartile range, and like by default it uses, but you can not only rely with this particular IQR. That's the box plot. Similarly, there's something called violin plot as well. Violin plot will give you the curve like structure. It is giving you the box like structure, but they tell about the same thing, that is nothing but the distribution of the data. You can also know the distribution of the data by plotting the curve, like this distribution histogram as well. This is nothing but the histogram at one side. This particular thing, it's just telling you like the smallest value, the largest value. Similarly here you will see the smallest value, the largest value this side, and like the frequency, how many times they are occurring. See, the thickness of this means most of the data points are occurring in this position, right? Because 100 is the mean. If you see here, 100 is mean, 50 is the standard deviation. So once again, if you if you do know a little bit of statistics, you'll be able to understand all this. If you don't, maybe you'll have to just go and get your hands dirty in statistics and then come again. And so I hope you are able to understand this. If you have any problem or anything that you want to discuss, you can ask me. So that's pretty much a fit for today. We'll see you again tomorrow, and we will talk about the exploratory data analysis and pre-processing. So we'll combine the the pandas pre-processing steps, and also we'll combine the visualization, and we'll see how can we get more information on real life data. So tomorrow we'll not be creating the data, we'll be using some real life data. Okay. And we'll try to do ED and pre-processing in them. So thank you so much for watching this video. If you liked it, do press the like button and subscribe to the channel, and follow my data science, machine learning, and Python lecture series for more. Thank you so much. We'll see you again in the next one. Till then, bye-bye and have a great day.